growth rates. Now, I should probably put inverted commas around growth rates, okay? Because the whole idea behind this is that when you say growth rate, how fast something is getting bigger or smaller, there are actually 5 different things that could be meant by this idea of the growth rate, okay? And what you hear about the growth rate, like what kind of additional descriptions there are, will tell you which of the 5 it is, okay? So I'm going to try and go through them one at a time. Now, we've got some different categories, okay? So up on the top, these 2 rows here, they're to do with time. Okay, they're to do with time. Whereas these vertical ones are to do with, how do I say this? Sort of like units, I suppose. You'll see why in a second. Okay? Now, do you remember, we were talking right at the beginning about why differentiation in calculus comes into this topic. Okay? Namely that if you want to know how fast something is growing, okay, and you know how much you got of it, the thing you do is you differentiate. Right? You differentiate. Now, the cool thing about having a function, right, and knowing its derivative, okay, even though we call that the gradient function, it's something quite different to knowing gradient, right? Because the gradient function gives you a precise gradient at a particular point, as opposed to get a gradient, you need 2 points, don't you? And then you do rise and run, etc. Okay? So therefore, the 2 distinctions between time correspond to these 2 ideas. Okay? So the first most important kind is an instantaneous growth rate. Okay? In other words, you freeze your situation, your scenario, at a particular point, t equals something, and then you say, okay, at this moment in time, not even a second or a minute, okay, at this instant, how fast is growing, right? Now, the opposite to instantaneous is to think about it over a period of time, right? So instead of, here's a, sorry, I'll do just one part of it. Here's something that's growing exponentially, right? To get that instantaneous growth rate, you're sort of getting that gradient, right? So it's at a point. But you can also think about it as 2 different times. So you've got this same growing thing, right? You can say, well, we started off here, and then a few time units later, we get up to there. So you work out, okay, well, what's that difference? Right. Okay. How long did it take us to get there? Run. And then you work out a gradient. Okay. Now, what would you call this versus this, right? This is sort of like velocity, right, at a particular point. This is kind of like average speed, right? It's over a time. It's changed throughout the time, but you can get a general idea of what's happening. So instead of instantaneous, you'll often see average growth rates. Okay. Tell me the average growth rate for the first 5 years, right? Now, in those first 5 years, maybe every year had a different growth rate. But you take the average of all of them, and you'll get one growth rate. Okay? Now, we're going to get into the details of how that plays out here. But there's also other ways to think about, right, well, how much is it growing? In relation to what? So, for instance, the most common way to think about it is in terms of absolute units. Okay? So if you've got a mass that's decaying, the absolute unit would be grams, right, or kilograms. How much actual stuff are you losing? Or if you're talking about a population, right, you're like, how many people, how many rabbits, how many bacteria, right? So that's, the units are in absolute terms there. Okay? But sometimes they want you to say, okay, how's it growing in proportion to where you started, okay? I was here and now I've got not 100 rabbits more, but I've got 10% more rabbits, or 20% more rabbits, okay? So because it's a percent, it's a proportion. It's kind of unitless. Okay, unitless. Now the last thing you might actually want, apart from say a number of rabbits or bacteria, or a percentage is, you might actually just want the function. Okay, which is different again, right? It's even less kind of units than this. This is like a percentage, a ratio, right? Derivatives have no units whatsoever. Okay. So what do each of these mean when we put them together, right? Well, instantaneous, absolute. Instantaneous, absolute. So I'm at a particular point in time, so it's going to have to do with a derivative, okay? And then I want, well, okay, how many rabbits are we gaining this year at this particular point in time? Or how many bacteria, right? So if we call it, let's say our function is P, okay? P for population.
Do you have the keys to C2.8?
Yeah. Should. Okay. Where was I? Okay, if we call P our function, right? Instantaneous and absolute. I'm going to want the derivative, which is dp dt. Right? But I want it at a particular point in time. Right? So I want dp dt when t is equal to, I don't know, some value which you specify. You know, at the end of the 10th year, or at the end of the 5th second, or something like that. Okay? So I'm using t1 to distinguish between t1's an actual value. Okay? So you can say t1 is real. Okay? Now, maybe a more concise way to write this, even though I don't like it, it is more concise, so I'm going to put it in for you, which is dp on dt, that's the first derivative, right? So you could call that p dash, right? So this is all equal to p dash at a particular place, namely at t1. So that's a 1, right? And that's a dash. So this is why I don't like dashes, but it's still a nice, concise way to say it. Okay. Okay. Now let's keep going. Now, if we want the average growth rate as an absolute, like how many of my actual things, okay? How do you work that out? We'll come back to our situation here. Okay. What you're going to do is you're going to say, how many things did I gain over this time period? How many did I gain? So how do you work out how many you've gained? You've got to know how many you had at the beginning, and then you've got to know how many you had at the end, right? So how many you had is P, the population. You're going to want to know the population at your end time, call that time 2. And then you subtract what you started with, right? Okay, now that's going to tell you the change in population, right? But it's not going to tell you a rate, okay? So what am I going to do? How am I going to turn a number, right? Between time 2 and time 1, I gained 5,000 rabbits. Okay? How am I going to turn that into a rate? Good. I want to divide by, well, how long did it take me to rise from this population to that one, right? If I'm comparing, you know, year 5 and year 10, I'm going to go 10 minus 5. So the duration was 5 years. There's my change. There's how long it took. Let's just rise over 1.